Element 24 on the periodic table of elements is chromium. I think that's how you say it. All right, this is Norris Teaches Science with me, Mr. Norris. This is another Physical Science Edition video. Today we're going to talk about nuclear decay, so it's something about nuclear chemistry. I have this video. I'm going to do one more video about nuclear chemistry. So today your goal is I can write nuclear decay equations. So before we begin, pause real quick. Make sure you have a periodic table in front of you because you're going to need it to write these equations. So nuclear radiation, what is it? It is charged particles and energy that is emitted from the nuclei of radioactive isotopes. We're talking about the radioactive elements on the periodic table. Now, some people like, yay, we're going to talk about Godzilla. Godzilla won't form from nuclear radiation. More likely, you're going to get what this kid had, which is cancer and tumors. I can't remember exactly where this picture was taken from, but I think this kid escaped from Chernobyl when it melted down and had nuclear radiation. But don't quote me on it. I can't remember exactly what the story was behind the picture. I got it a long time ago. There's three types of nuclear radiation: alpha, beta, and gamma. So before we begin, just so you know, this is how we write symbols when we're in nuclear chemistry. It's different from what we've done before. Instead of the atomic number at the top and the mass number at the bottom, the mass number is going to be at the top, atomic number is going to be at the bottom, then you will have the symbol. Just so you know. So I pause this video, maybe write this down because this may be important when you do stuff later. So alpha particles, they are positively charged. They're composed of 2 protons and 2 neutrons. We know that it's positive charge because a proton is positive and a neutron doesn't have any charge. So that would mean that it's positively charged. There's no electrons with alpha particles. The thing is, alpha particles are kind of weak. They can be stopped by a thin sheet of paper. We express it as 4,2He or the lowercase alpha symbol. But in this case, you're going to write the 4,2He. You're not going to write the alpha symbol, just so you know. And also it has a mass of 4 AMUs because of the mass number being 4. That's what the 4 appears for. Because remember, mass number is determined by the number of protons and number of neutrons added together. A beta particle is negatively charged because it only consists of electrons. Beta particles are a little stronger than alpha particles because the thing that stops a beta particle is aluminum, which is a little thicker than just a sheet of paper. Now we express beta particles 2 ways. We have 0, -1e, which means we're going to write it like that when we do stuff today, but you may see it as the uppercase beta symbol. And they have a very small mass just because they're composed of electrons, and electrons have a very small mass. Remember, because they're composed of electrons, that's why they're negatively charged. The other one is gamma rays. These are the highest frequency on the EM spectrum. In a future video, we're going to talk about the EM spectrum, also known as the electromagnetic spectrum. Gamma rays have no mass or no charge because they are composed of energy. Things in physical science can be composed of matter or they can be composed of energy, and there's 2 separate things. Now, gamma rays actually are very powerful. The only way to stop them is to have 3 meters of concrete or 3 centimeters of lead. And we usually express it with the lowercase gamma symbol. Now, elements can experience 2 types of decay. The first one's called alpha decay. This is when the element releases an alpha particle from the nucleus. And so the product is usually 2 less protons and 2 less neutrons, meaning the mass number is going to decrease by 2 and the atomic number is going to decrease by 2. And when if you can see here, here's the atomic number of what started. Since the atomic number changes, it changes the element. All right, so let's do some practice with it. It says, write the balanced nuclear equation for the alpha decay of polonium-210. All right, We know we're messing with polonium-210. Get your periodic table out. So, find polonium and tell me and look up the symbol. I'll give you a hint. The symbol is PO. All right. Now, polonium-210, 210 represents its mass number. Remember that from isotope writing. So 210's up here. Decay is really associated with different isotopes. Now at the bottom we need to know what its atomic number is, and its atomic number is 84. All right, then we do an arrow, and I know that I need to have a blank plus blank. And the first blank will be the new element, and the second blank will be the particle that's emitted. Since this is alpha decay, the second blank will be 42He. The next one, we know that it's an alpha particle that came out, means it's an alpha decay. That means the mass number is going to decrease by 4. So 210 minus 4 is 206. And then the bottom number is the atomic number. And since it's alpha decay, we know that the bottom number is going to decrease by 2. So that means that it's going to become 82. Now that we have a new atomic number, we have a new element symbol we need. Look on your periodic table. Find element 82. When you do that, you find that the element symbol is Pb, which is lead. And this is the alpha decay practice and how you would do it. Beta decay is a little different. This is where a neutron decomposes to a proton and an electron. The proton stays in the nucleus, but the element releases the electron. The mass number will stay the same, but the atomic number is going to increase by 1. Mass number staying the same because, remember, mass is the combination of neutrons and protons. When you just have a neutron become a proton, the mass didn't change much. But the atomic number is going to increase because you added 1 extra proton. So if you see in here, we have started with thorium with 90 protons. Then we will go to Pa, which has 91 protons. All right, let's do some practice with it. Write the balanced nuclear equation for the beta decay of carbon-14. So the first thing we have to do is have to write what we start with. We're starting with carbon. Carbon is C, and the mass number they give us is 14. Now we need to figure out what carbon's atomic number is. So look on your periodic table, you would find that carbon has an atomic number of 6. We do an arrow, and just like in alpha decay, it's blank plus blank. In the second blank, we're going to write whatever particle is for whatever decay. Since this is beta decay, we're going to write a beta particle, which is 0, -1, lowercase e. All right, in the next one, we're going to write the new information from the decay. When we do beta decay, the top number, the mass number, stays the same. You just transfer it over. The bottom number, you're going to add 1 to. So 6 plus 1 is 7. Now that we have a new atomic number, we have a new element. Look at your periodic table. What element is 7? That is nitrogen. And this is beta decay. I hope you learned something today about nuclear chemistry. There's a whole bunch out there about nuclear chemistry. Maybe even go look up some of the nuclear disasters out there like 3 Mile Island, Fukushima, and Chernobyl. Those are very interesting stuff that happened. Fukushima, I'm making this video in 2020. It's one of the newer disasters, but look up Chernobyl. Don't watch the video Chernobyl Diaries. It's nothing like that. All right. I hope you learned something today, and I'm Mr. Norris, and I'm out for this video.